This video is going to talk a little bit about some of the patterns we see in the periodic table that might be helpful for you as we start talking about what our atoms do and don't do. So the first pattern that we see is that our periodic table is organized by families. The families are each of these columns that we see that our periodic table makes, and those columns are helpful because each of these families have the same number of valence electrons. We're going to generally skip the dip for now because they don't really follow any of these patterns, but the rest of them do. So family 1 here has 1 valence electron, family 2 has 2 valence electrons, family 3 has 3 valence electrons, family 14 has 4, 15 has 5, 16 has 6, 17 has 7, and this last family of noble gases, neon and down have 8, helium has 2. So this is how many valence electrons everybody has. Now, remember we talked a little bit about ions before, and I told you that some of them like to gain and some of them like to lose. So we're going to talk just a little bit about that here. So remember, everybody forms an ion when they want to look more like a noble gas. So they either want to look more like neon and whoever's down here, or they want to look like helium. So whoever's in this family of noble gases. So they're going to either lose or gain electrons in order to look more like this noble gas. So if I'm looking at family 1 and I see that they normally have 1 valence electron on their outermost shell, what they can do is they can either try to get 7 more electrons to get to 8, or they can give up 1 of their electrons and then their inner shell, which is already full, becomes its outermost layer. So what ends up happening is it's easier for family 1 to give away 1 electron than to find 7. So what they'll do is they'll give up 1 electron, so they'll lose a valence electron, and that will give them a positive charge because they lose a negatively charged particle. Family 2 has 2 valence electrons. It's easier to give away those 2 valence electrons than to try to get 6 valence electrons to get to 8. So they end up losing those 2 valence electrons, which give them a 2+ charge. So family 2 typically makes 2+ cations. Family 3, mostly family 13, aluminum down here, they have 3 valence electrons. So again, it's easier for them to lose those 3 valence electrons than try to gain 5 electrons to get to 8. So they'll lose 3 valence electrons, making them a cation of 3+. Family 14, because they have 4 valence electrons, do they want to lose 4? Do they want to gain 4? Typically, they don't follow our pattern. I will say most often they form negative cation or negative anions, but again, no real pattern like the rest of them. So we're just going to skip them for now and go to family 15. Family 15 has 5 valence electrons. So in this case, instead of giving away 5 electrons, it's actually easier to get 3. So they'll gain 3 electrons, which gives them an overall charge of 3-, because remember, electrons are negatively charged. Oxygen's family are 16. They have 6 valence electrons. It's easier to find 2 electrons than try to give up those 6. So they gain 2 electrons, giving them a 2- charge. And then family 17, they only need 1 more electron to look like a noble gas, so they'll gain 1 electron. So they generally make a 1- anion. So that's the pattern that we see. Again, this dip right here does not really form a pattern, so we don't have any patterns for them. Neither do these elements underneath the staircase over here. Just a couple of more informative bits about your periodic table. Your metals are on the left of your staircase. So on your periodic tables, you'll generally notice a staircase that comes down on this side. Everything to the left of it is a metal, and those all form cations. So your metals will always form cations. And then some of your cations are a pattern, right? So family 1, family 2, and family 3, we know what kind of cations they form. All these other ones form various other cations. Anything to the right of your staircase is a nonmetal, and they all form negatively charged anions. So that's what I was saying about these carbon. If they do form an ion, which they don't a lot of the times, they would form an anion. Your noble gases don't ever form any ions, but they are still nonmetals. When we're talking about your periodic table, when we're talking about the rows horizontally, those are called periods. When we're talking about the columns, when we're talking about the vertical parts, those are the families. And the families are really important because members of the same family share the same number of valence electrons. And because they share the same number of outermost electrons, they often behave most similarly. So they're the ones that will have similar chemical properties.